Okay, so now let's look at question 3C, D, and E. Each of these involve log. So when it comes to solving equations that involve log, there's three main cases. So in case one is where you have a log statement completely on its own, and then you need to convert it to exponential form. Okay. So what you would want to do here is the log 2 8x. We want to isolate that, which means this 3 that's being multiplied to it, we could divide it out. So we're going to divide both sides by 3. We get log 2 8x equal to 10. Now we're going to convert this log to exponential form. The way that happens is, since this is base 2 here, this base will go here, and this 10 becomes the exponent of the base 2. So we end up with 8x equal to 2 to the power 10. So this 2 is your base, and the 10 became the exponent. Right? And then finally, well, we just have to isolate x, so we just divide out by 8, and we get x equal to 2 to the power 10 over 8. And then we could put this in a calculator and see what that's equal to. I'm just gonna keep it like this for now. But since I don't have a calculator for me, you can go ahead and put that into a calculator. Okay. The next question, 3D, is you'd want to use log properties here to combine any of the log expressions if you have a bunch of sums and differences. So here we're having these two expressions, they're being subtracted. So let's use the quotient property that would make the subtraction into division. So we get this. Now this is similar to what we did in question 3A, where we can establish an equivalence property. So in the case of logs, equivalence property says if you have log of base of something equal to log of the same base equal to another thing, then you can just take those and set those arguments equal to one another. So in case of in relation to our problem, well, since this is log base 3 and this side we have log base 3, therefore we can just say x plus 1 divided by x minus 3 equals 2. And now we could solve for x algebraically. We can multiply both sides by the x minus 3 in order to get rid of it. We get x plus 1 equal to 2x minus 6. Let's subtract the 2x, and let's subtract the 1. It gives us negative x and negative 7. So x equals 7 for this problem. Okay. Now I always recommend, again, taking the number and plugging it back into the original statement to just make sure that's valid. So if I put a 7 here, I would get 7 plus 1, which is 8. And that's a positive input. Okay. Here, if I put in 7, I get 7 minus 3, which is 4, which is also a positive input. So you want to make sure the inputs of your log functions are positive. So we get log 3 of 8 minus log 3 of 4. And just using the properties, that tells us that we have log 3 of 8 over 4, which gives us log 3 of 2. Okay, so yes, this answer is valid. Okay, now the last one, we have to it looks very similar to 3D, but the only difference is there's no log statement on this side of the equation. There's only log statements. Oh, there's a mistake here. Okay. There's only log statements on the left-hand side, but not on the right-hand side. So we can, we're not gonna have the equivalence property for 3E. Right, so let's start off by combining these using the log properties. Well, in this case, they'll multiply because they're being added. So we get x squared plus 7x. Well, now, because we don't have log on both sides and we don't have an established equivalence property, rather what we're going to do is similar to what we did in this problem. So we take the 2 and convert this to an exponential. We end up with x squared plus 7x equals 2 cubed, which is going to be what, 8? Okay, now this is x squared, which means we can establish a quadratic equation by moving everything to one side. And then we can either use the quadratic formula, or if possible, we could factor. In this case, yes, this one can be factored to give you x plus 8 and x minus 1. But if you get a quadratic, again, you could either factor it if it's possible, and if not, go ahead and use the quadratic formula. So this tells us two possible values for x. X equals -8, and then x equals positive 1. Okay, now when you have more than one solution, definitely make sure you check whether or not they work for the problem. So let's just move over a little bit. Okay, so let's go ahead and check our possible two answers. Let's start off with x equals -8. If I put that into our original problem, I get log 2 of -8 plus log 2 of -8 plus 7. Okay, already this doesn't work because you can't have a negative inside. So this is a undefined statement. So x equals -8 is not going to work. Okay, and then let's check x equals 1. Well, we get log base 2 of 1 plus log 2 of 1 plus 7. Well, log of anything that has a 1 as the argument would equal 0. And then here we get 2 of 8. Well, log 2 of 8 is the same as 2 cubed because 8 equals 2 cubed. So that gives us 3 log 2 of 2 using the properties to move the power. And these are the same base, so we're left with 3, which is what we have here. So x equals 1 is the answer to this problem.